Started recording? So in the previous class, we have discussed communication protocols, I think. So continuing our discussion, so today we will discuss the next topic of IoT, it is IoT enabling technologies. IoT enabling technologies. Means enabling is the technologies which make happen. IoT make happen. Now let us understand. Now if you want to connect this tubelight or this fan, or if you want to make this tubelight or fan a Internet of thing, what should we do? We have to connect it to the internet. Very good answer. Now if you want to connect to the internet, what should we do? Recall first class. First we have to make it as a embedded system. Very good. You have to make it as a embedded system. So what we have seen, what is embedded system? Embedded system is microprocessor or microcontrollers plus software, that is program memory plus memory, right? Memory should come second, plus some IO devices, right? These are the requirements to become a IoT. What is its functionality? It performs a desired task repeated. Desired task repeated. Right? So now we have to make it as an embedded system. Then we can connect it to the internet. So what we should do if you in order to make this fan or tubelight an embedded system, what is the first and foremost thing? We need microprocessor or microcontroller. We need microprocessor or microcontroller. Now question arises, so what is this microprocessor? Though being a CSE student, you know it. You might be knowing it. But what is a microprocessor? Sir, this is a microprocessor. Sir, this is a chip. Sir, this is a microprocessor. But how to define it? What are its characteristics? Sir, it is made up of a semiconductor. Right, okay. But what is its functionality? First and foremost, a microprocessor is a digital IC. IC is integrated circuit, of course. It is a digital integrated circuit. It is an integrated circuit. Now the question arises, what is integrated circuit? Sir, we have seen in the digital electronics lab. Whenever we open some boards in mobile or when we open a laptop, we see ICs, sir. Integrated circuit. Integrated circuit. It is a circuit. Yes. Have you done analog electronics lab, basic electronics lab? You have seen resistors. Remember, recall? You have seen capacitors. Yes or no? You have seen inductors. You have seen diodes. Right, you used to connect like this. A voltage source, a resistor, a capacitor, a load, inductor. These are all called as, this is called as a lumped circuit. This is called as a lumped circuit. Here, all those circuit elements are in the form of lumps. Now in integrated circuits, all these are combined, integrated on a silicon wafer. These are created and integrated on a silicon wafer. A silicon wafer whose thickness is negligible. Right. So we take a silicon wafer with all those, right, in the size of micrometers, in the size of nanometers. All those capacitor integrates, right? We integrate them on a silicon wafer. We integrate them on a silicon wafer. Then we take a case. Then we take a case and we package it. Then we have connecting pins. We package it. Right. Then we have connecting pins. Right, the logic is that you see digital electronics, right? That ICs. Basically, it is packaged one. It is a plastic package. Inside there is a silicon wafer. Right. Inside there is a silicon wafer on which we have fabricated, right, all these components. Let us not get into deeper. Right. Let us keep understand this much. Right. So these are the digital integrated circuit. Microprocessor is basically a digital integrated circuit. Now, what is the meaning of digital? What is the meaning of digital? Yes. What is the meaning of digital means the microprocessor takes input in the form of zeros and ones. That is what we call it as bits. Processes zeros and ones. Process zeros and ones. Gives output in the form of zeros and ones. Hence the name digital integrated circuit. You go to digital electronics lab. Don't think of giving analog signal as an input. In digital electronics lab, the moment you enter the digital electronics lab, what should come to your mind? In digital electronics lab, the inputs are in the form of zeros and ones. Whatever components are available in digital electronics lab, the input we have to give in the form of zeros and ones. Output will be generated in the form of zeros and ones. In between, right? When we give input, it processes the input which are in the zeros and ones. Then it gives the output in the form of zeros and ones. The moment microprocessor you say, what should come to your mind? Inputs, zeros and ones, that is binary digits, outputs, binary digits. So then when we write a programming language, how it goes to microprocessor? Right, you will understand all those things. We say that as a machine language. Basically, the microprocessors understand the machine language. Is it fine going on? Yes, sir. Right. Then, what is the one more thing characteristic here? It is a clock driver. It is a clock driver. It is a clock driver. You see these pictures like this here? Clock swing due to the as one of the input. Positive trigger, negative trigger. It is a clock driver. We need clock. We need clock. Like today, we also need clock, right? At 9 o'clock, the classes start. The class will run from 9 to 10. We need some reference. At what time an event triggers? The class starts at 9 o'clock. For how much duration? So for all those things we need clock. So here, clock, what does clock do? It triggers the events. It triggers the events. And for how much duration? For how much duration? For 3 clock cycles, for 4 clock cycles, for 5 clock cycles. Why clock is necessary? Because what does the microprocessor do? Microprocessor does a series of events. It does a sequence of events. What is program? Program. We translate program in the Telugu or in Hindi. Karyakram. Karyakram. A sequence of events. It is a sequence of instructions. Each instruction is a command to the microprocessor. We say now what is a program? Program is a sequence of instruction. What is an instruction? An instruction is a command to the processor. Command means what? We are telling the processor what to do. We are telling the processor what to do. Right. So when we have a sequence of events, we need clock. Two reasons are written. It triggers the event and for how much duration. For how much duration. Is this idea clear? Now, one more characteristics I have. It is a register based. It is a register based. Register. You have come across. You have studied digital electronics subject. You have come across registers. Registers are meant for storage of data. If it is 4-bit register, it will store 4-bit data. If it is 8-bit register, it will store 8-bit data. Each register, right? Each bit is stored by a flip flop. Or register is made up of a flip flop. You have studied all these things in digital electronics. Recall, right? So it is a register based. Why we need register? Because inside processor for temporary storage of data we need registers. For example, if I want to add 2 plus 3, if I want to add 2 plus 3, I have to bring 3 to the processor. When it comes to the processor, where I will store? I will store in the registers for temporary storage of data. The result is produced as a file. I have to store it temporarily till I move into the microprocessor. To the memory. So we need registers. Right? Now. Now, it is a multi-purpose. Of course, right, multi-purpose. It can be used for computing, it can be used for embedded system, whereas it finds applications suitable, we can use it. Multi-purpose. As the word says, it is many purpose. Here, this is the hardware part of a microprocessor. What is the functional part? Right. So first point is this one. It is a multi-purpose. We have understood. Why it is register based, we have understood. Why it is clock driver, we have understood. Why it is digital, we have understood. All these characteristics should sit in your mind. Tomorrow, if somebody gives the microprocessor, you start giving the analog signal to it. It should not happen. Somebody interview is going on, or so they have handed over the component to you. They will ask you to supply. They will give signal all those components to you. You start giving analog signal to it. Done. Fail. Things are minute, silly, but you have to keep in mind these fundamentals. Clear? You should not forget to give the clock. That also you should keep in the mind. You suddenly are sitting on an interview table, right? You have an interview for ISRO, ISRO. You have an interview for DRDO, right? They ask you to design a sequential circuit. They will give you. If you forgot to give the clock input, done. They at the first moment they will understand. Gone. Clear? Now functionality. What does it do? It accepts inputs in binary form. Yes, binary form is zeros and ones. It accepts the input in the binary form. Here in the picture you are seeing. And most important point, processes it means what? Inputs. According to the instructions stored in the memory. This point you should keep in the mind. It processes the inputs, it does some actions on the input based on what? Based on the instructions that are stored in the memory. Where is the memory? Till now we can say it is not on the microprocessor. Till now we can say it is not on the microprocessor. It has to take externally. Right? You can see one by one. Right? What do you understand? Memory. Here there is a memory. Instructions are stored. Instruction 1, instruction 2, so on. It will take from the memory. It will take one instruction from the memory, it will understand that instruction, according to that instruction it will take the inputs and it process. Is this idea clear? It takes the input, process it according to the instructions. Where the instructions are stored? They are stored in the memory. Right, and produces the output, right, or what we call it the results in as binary. The very important point in the functionality part, this is the structural part. This is the functional part of microprocessor. The key sentence, the key idea here is it processes the input according to the instructions. That you should keep in the mind. What are instructions? They are in the program. Who are writing the program? Human beings are writing the program. Means microprocessor is simply doing what human being is asking to do it. Remember, we are not still right. We are studying this subject. We are not studying artificial intelligence subject. That is separate thing. That we can come later. Are you getting me? Till now, what is the knowledge? It is doing what human beings is asking to do. It is doing what human beings is asking to do. Is this idea clear? Right. So, of course, we will have to perform a desired task. That is understand. All things are like they are not doing it for some action to fulfill a desired task. Is it clear? Is this definition sitting in your mind? As simple as it is. I have shown you the picture. One should not forget it. Is this idea clear? So how does it do it? What is the architecture of a microprocessor? Simple block diagram. What does it contains? Right. So the moment I say microprocessor, you should say it has registers, has control unit, it has arithmetic and logic unit. So microprocessor is equal to CPU. Thing is clear? Microprocessor is equal to CPU. What does it contain? Registers, as I said, for temporary storage of data, control unit, arithmetic and logic unit. Right. So here registers, control unit, CU, arithmetic and logic unit. Control unit, arithmetic and logic unit. Now, where is the program stored? First we write the program in high level language. First we write the program. We write the program in high level language. Like this we have written the instructions. Like this we have written the instructions. This is given to the, this is compiled or interpreted, linker, all those things happens. You know already, you have tried to compile or something. Then it is converted into machine level language, which is zeros and ones. These are the instructions now. These are the instructions now. Now, where we are storing? We are storing it in the memory. We are storing it in the memory. Then in the control unit there is something called as instruction program counter. Program counter contains the address of the next instruction to be executed. That address is given here. Right. I have an instruction decoder. This will move. Right. This is address bus. This is data bus. This will move here. Right. What we call it as a instruction decoder. Decoding the instruction. Decoding the instruction means the set of actions that microprocessor has to take. All those control part will be taken by the control unit. Controlling part. Once it comes, instruction decoder. So how this functions? Functions in 3 cycles. Fetch is the instruction. How will you fetch the instruction? The address that is present in the program counter. Then decode the instruction. Fetch instruction. Decode the instruction. Decoding means understanding what the instruction has to do. What actions the instruction is telling you. Right? What do you mean by instruction? Command to the microprocessor. Command means what to do. It will decode it. Then execute. What does it say? It is saying add. This instruction is saying add 2 plus 3. Once it is decoded, it will take 2 from the memory and it will bring it to the register. It will take 3 from the memory and it will bring it to the register. From the register, it will move to the ALU. ALU performs arithmetic and logical operations. ALU performs arithmetic and logical operations. And this 2 plus 3 is equal to 5. Execute. Go for fetching the next instruction. Bring that instruction to the microprocessor. Decode it. Execute it. Is this idea clear? Fetch, decode, execute. This is how the microprocessor works. Now the next is most important question. Right, as Mr. Abdul has been asked, he has one asked at the starting of the class. Sir, what is the difference between microprocessor and microcontroller? What's your question? Now we will see. Right. Right. So microprocessor is equal to CPU. Now it is taking the instructions from the memory, which is external. Which is external. Right. I will use a different diagram here. It is taking instructions stored in the memory. Then say I will make it as to be specific RAM ROM. Let us not talk what it is. I think at this point of time you know this. Nowadays RAM ROM, all these are like even if you apply for police constable job, these questions it is general knowledge. That is a part of a general knowledge. But here, what is our understanding? These are connected. Right, dot and memory. These are connected externally. It could be one same some IO components like I2C and all those things. The hardware required to connect the IO devices. Right. Say clock. This clock driver, we need clock. It is clock driver, we need clock, yes. In our laptops, in our desktop PCs, we have a CMOS battery, to support the timer clock. Right. Now, okay, let's see now. Let us not get into more hard details. All these are connected externally. What is say? All these are what I am say connected externally. But for embedded systems, for Internet of Things, we need our devices as compact, as small as possible. For remote applications. For remote applications. Right. See, if I am using this tubelet, I am making this fan as an embedded system. Here the whole system is becoming bigger than this. Are you getting me? For 25 paisa work, we are spending 75 paisa. Right. What you said? There is a famous saying of them. Right. Charlie ki murgi, baali ki masala. Right. Like that it will happen. Right. The translated people are like they are eager to know. Right. Clear? Now, what is the solution? All these things bring on to a single IC. Bring on to a single IC. Microprocessor, that is then RAM, ROM, IO, clock. This is microcontroller. Is this idea clear? There are two reasons. Consumes more space. It consumes more space. Expensive. Here, on a single IC, we are bringing out this less space, compatible devices as we require for embedded systems and Internet of Things. Right. And cheap. Comparatively less cost. Less cost. Right. So, it is consumes more space. Compact. It has connected externally to access. It takes time. Less speed. All are available on the ICs. More. See, within some domain only we are discussing all the things. Sir, you are sir, nowadays, yes, microprocessor has advanced. Right, their working speed has been increased. Right, today they are available at 2.5 GHz microprocessor. Keep that apart. Let us understand basics. Right, see, because why it is more less speed? Because every time it has to go outside to bring the data and therefore instructions, right? Here they are available on the IC itself. Clear? Now you tell me which is better, is microprocessor better or microcontroller better? Very good. Depending upon the applications, because it has also some cons, it has also some cons. Right. Here the capability is high because capability is more. Because I can do add-ons. I can increase the size of the RAM, I can connect it externally, I can increase the size of the RAM, I can connect externally. Yes or no? I can increase the size of the memory, but it is already fabricated on the IC. Right. So limited capacity, the down things to understand according to the context. Is this idea clear? It is about where we are using them, what are the applications. Is this idea clear? Right. So, of course, Cost is more, cost is less. Applications, computing, for computing purpose, for mathematical calculations we are using. Applications, embedded systems. Embedded clear. Uses in personal computers, in laptops, mobile phones. Here uses washing machine. That is what I call it as a home appliances. I call home appliances, etc. Here also etc. Here also etc. Is this identity? You should keep these things in mind. Right. Here has limited capability. Right. Capacity or capability? Because capacity, limited capacity because I cannot increase the size of the RAM and ROM. Hence capability. Capability is potential. Yes or no? Clear? I think hope this is clear, right? What is the difference between the microprocessor and the microcontroller? At this point of it is clear. Right. Functionality same. Fetch, decode, execute. This has to bring from another room. In the sense that contextually, don't forget it has to go another room. Right. Here this diagram has to go outside to bring those required components, those recipes. Right. Here they are available within the IC. Right. Power consumption is more. Power consumption is less. You reduce all those things. Are you getting me? Right. You do more work for this. So I will list some microprocessors. I will list some microcontrollers. Here are the right. So example of microprocessor. Right. I have 4-bit microprocessor which was developed in 1971 by Intel 404. Right. So 8-bit microprocessor came in 1974. Right. Which was Motorola 6800. Then 16-bit microprocessor in 1978, which was Intel 8086. You understand what is 4-bit, what is 8-bit, what is 16-bit? Right. When I say 8-bit microprocessor, at once it can act on 8-bit data. 2 is a 8-bit data. For example, 2 plus 3 we are adding. 2 is a 8-bit data. 3 is a 8-bit data. The result 5 produced will be 8-bit data. It processes also 8-bit. Right. Now today latest, so we have a 32-bit microprocessor. When it is 1993, it is Power PC. Power PC 601 something. Right. I am giving you the rough idea. The so first 64-bit came. Right. So in 2000, right. Earlier it came. The example I am giving is 64-bit AMD Ryzen in 2000. It is not that I am saying in 2010 it has came first, but I am giving you the examples. Some timeline, so that you should imagine. You should have some approximation how the evaluation is taking on. Evolution, not evaluation. How evolution is taking on. Right. Darwin's theory of evolution. Right. Right. I never found like we are evolved from monkeys. He never written that. I don't know. Has he written? Are you sure about the literature? Are there explicit words that human beings have evolved from monkeys? I don't think so. Right. See, if you ask me, everybody has evolved from amoeba. Are you getting me? Everybody has evolved from amoeba. If you ask me, first living being, right? So again, let us not get into details. Something evolution word came and said. Is this idea clear? So let us see some microcontroller examples. We have families, ARM Cortex, area 22, at mega, 22 at mega microcontroller, big microcontrollers, A16, 32 bits. Right. Is this idea clear? Then we have some sensors, we have actuators, input output devices, we understand, right? Also in embedded systems we will have some actuators, we will have some sensors. In the previous classes what I said, sensors is convert any physical quantity into electrical signal. In the earlier class I explained. This is vice versa. Right. So this is the right. Now all those peripherals. Now I can connect it to the internet. I will have a Ethernet port or Wi-Fi embedded on it, and I will connect it to the internet. Hence, embedded system is a enabling technology of the IoT. Is this idea clear? What is the point? Why it is enabling? Because of this reason. The embedded system is the enabling technology. First we have to make it embedded system, then only I can connect it to the internet. Is this idea clear? Right, what is your name, man? Santosh. Where is the board? Those boundary lines you keep bad. Next is wireless sensor networks. You don't have a bike or car in your home? You have a bike? Car? So what's like this only? Right. Second is wireless sensor networks. Wireless sensor networks. Famously called as WSN. See, there are 5 technologies. I will write here 5 additional technologies. One is embedded system. Second one is wireless sensor network. Third one is big data. Fourth one is cloud computing. Fifth one is communication protocols. This is over. This is we have covered in the physical design. Now embedded system is over. Wireless sensor is there. In the other class, I will go for big data analytics, cloud computing. Right. There I will record it. So 2 in this class, 2 in that class, and the electrical exchange. Are you getting me? Again, like you already before we have to cover. Right. See, already people started writing attendance sheet. How futuristic, how vision. Right. Right. So this is called what you say innovation in India. Right. Wireless sensor networks. First and foremost, there is lot of information in the full form only. Wireless. See, let us take the example of forest, fire, acres of forest. Right. We need hundreds of sensors. We need hundreds of sensors because if I keep one sensor at the end of the forest, at one side of the forest, fire occurs at another end. The sensor will be not detected. Sensor has a range. It has a range to detect. Are you getting me? Now we, for 1000 acres of forest, suppose, imagine, see, assume, it is assumption. I require some 200 sensors to detect the fire. Fire is a physical quantity. It has to be converted into electrical quantity. Once it is converted into electrical signal, can I give to the microprocessor?
Yes, yes.
No. Think what you said minutely. Also I have to convert it into digital signal. You should remember that analog to digital converter. For some microprocessor, ADC is also available on the chip only. For microcontroller, right? So that was a generic diagram. Don't detect that is exact diagram. That is a generic diagram. Are you getting me? Generic means more general, right? Even ADCs are present on the microcontrollers. For microprocessors, we have to connect it externally. Right. Now, these 200 sensors, I am placing it all over the forest at some intervals, some distances, separated by distributed devices. If I keep on connecting these 200 wires with the wire, I will go mad. It is not practical. First fire occurs, wires will only burn. Are you getting me? Wires will only burn. Purpose is bit. So we have to make it wireless. The sensors should communicate wireless without wire. Is this clear? So in wireless sensor networks, the first characteristic is wireless. Now sensor. Here if you ask me what is in wireless sensor, wire. No. If they ask actuator, no. It is wireless, it is sensor. In this network there are no wire things, no actuators. Sensor. We have seen sensors and actuators. But here in wireless sensor, that's why I said in the full form itself, in the name itself there is a lot of information. Wireless sensor networks. Right. Tomorrow if there is an actuator in your sensor networks, you should throw it out. Are you getting me? If there somebody has to design a wireless sensor network for particular application, in an order you have ordered an actuator also. Gone. Is this idea clear? Right. Why we need wireless we have understood. Why it is sensor we have understood. Right. Now, what we have here? What are the characters? What are the role players? What are the actors here? We shall see. Right. So here, of course, we have microprocessor or microcontroller to which we have connected the sensors. Right. Here I have. Here one I have. Again one sensor I have connected. Another sensor I have connected. What I have to connect? I have to detect the fire. So temperature sensor I will use. I can also use smoke sensor. I am connected. Right. Here one microprocessor microcontroller to which I have connected a sensor. Another one because I have to distribute throughout the forest. Right. Another one here. Same. Another one here. I am drawing these many things because it is I need it for explanation. They are part of it. This is why is that one? We know. Right, they are sharing the information. So it is a wireless sensor network. Here, each one is called as an end node. Each one is called as an end node. Right. So here we have a nodes. To the nodes, sensors are connected. What are nodes? We know the microcontroller board. Then some peripherals to it. Right. So here, what are the characters we have? We have EN. EN is what? End nodes. To which sensors are connected? To which sensors are connected? To which sensors are connected? Now, second point. These end nodes are also called as routers. Their another name is router. End node, router. End node, router. End node, router. End node, router. This should sit in your mind. What does this sensor do? This sensor measure environmental and physical quantities. Environmental and physical quantities. The example, temperature and smoke in case of to detect the fire. Now question arises, why these are also called as routers? You as a computer science engineers, you have already studied computer networks. Yes or no? Yes. You know the routing, routers. Yes. Clear? So these are also called as routers. What is the meaning of routing? Shortest path. Choosing the shortest path, less traffic path. Less traffic path. What is the meaning of the routing at this point of time? To keep it simple, right? Shortest path, less traffic path. Why here? Because now I said no, why it is. Now, here one more character is there. What is that one more character? The one more character is coordinator node. Coordinator node. Here I have a coordinator node. Coordinator node, which helps to wireless sensor network to connect it to the internet. To connect it to the internet. This coordinator node is also called as gateway. Gateway. Now you are in this campus. If you want to connect it to the outside world, you have to go through the gate. You have to go through the gate. Here also, if they want to put the data into the internet, you have to go through this coordinator node. Now the question arises, why routing? Because now suppose this end node has collected the sensor data. Now it has to give it to the coordinator node. It has to give it to the coordinator node. Right? It has to give it to the coordinator node. So how? Will it give directly? No, it has to choose a path. Whether it has to go like this, or whether it has to go like this, or whether it has to go like this. What is the criteria? Shortest path and less traffic path. And they are also called as routers. Is this idea clear? Now we have coordinator way. The coordinator is called as also gateway. Why? To connect to the internet. Is this idea clear? Yes or no? As simple as they are. Nothing complex. Right. So target is each end node, right? And see 50 paisa point. We are trying to keep each end node as much as size as 50 paisa point with a battery attachment, button back. Are you getting me? Just throw out of the forest. Throw the forest. Battery dead. Expiry gone. No research. Searching again. Replacing battery. Nothing like that. Done. Use them. For forest fire detection you can use. For landslide. Nowadays you are seeing that in north part of India, in Jammu and Kashmir landslides. Yes or no? There, in the valleys of the mountains, we place these sensors. When the landslide occurs some 2 kilometers away, before it reaches down the valleys, we can detect them. Yes or no? There is an alert message. Can it be done? Like that, you have to think variety of applications. Right. So is it clear? Pause it. Close it.